Now, after finding out the surface area of the combinations of the solid, we are moving on further with our second concept, in which we will talk about the volume of the combination of the solids. Now we are talking about the volume of the combination of the solids. So let's just see an example which is related with it. So the very first example is a solid is in the shape of a cone standing on a hemisphere with both their radii being equal to 1 centimeter, and the height of the cone is equal to its radius. So it is already given to us that the height of it is actually nothing but is equal to the radius, and further it says find the volume of the solid in terms of pi. It means we do not have to solve the value of pi, we have to take the volume remains as pi. So let's just form the figure for this one. So as you can see, we have the shape of a cone and a hemisphere. So this is nothing but of this form. You can see all by yourself that the cone is actually standing on a hemisphere over here, and let us suppose if I'm just starting with the radius. So according to the question, if I'm just starting with the solution of this one, so we know that their radii are equal to each other, and their radii is nothing but it is given to us, this is nothing but 1 centimeter. So this is nothing but 1 centimeter. So if this is 1 centimeter, then it is also nothing but 1 centimeter. Its height is again 1 centimeter, and further we know that the height of the cone is just the same as that of the height of the radius. What does it mean? It means that its height is also 1 centimeter. Its height is also nothing but 1 centimeter. This height is nothing but also 1 centimeter. So let's just write it over here. First of all, the radii of cone and hemisphere is nothing but is equal to 1 centimeter. Further we have the height of the cone is equal to the height of the hemisphere, which is nothing but again 1 centimeter. Now we just have to find out the volume of the whole particular solid. So the volume of the solid is definitely is equal to the volume of the cone plus the volume of the hemisphere. It should be is equal to of this form. So hence it is nothing but is equal to volume of the cone. What is the volume of the cone? It is nothing but 1 by 3 pi r square h. We know that the volume of the cone is 1 by 3 pi r square h. What is the volume of a hemisphere? It is 2 by 3 pi r cube. We definitely know that the volume of the cube is nothing but is equal to the volume of the sphere is nothing but is equal to 4 by 3 pi r cube. But here we are talking about the volume of the hemisphere, so it should be half of the sphere, which is 2 by 3 pi r cube. Now let's just sort it out. First of all, we can see over here we have to take pi by 3 common. Let us suppose if I am just taking pi by 3 common out of it, and further I am just taking r square common out of it again. Further we can see we have taken pi r square by 3 common, so this would be nothing but h plus of further we have this 2, we have this 2, and pi r square by 3 is already common, so we have h plus 2. Now let's just sort it out. This would be nothing but pi by 3. Radius is nothing but 1 whole square. H is nothing but 1 plus 2, so this is nothing but is equal to pi by 3 into 3. 3 and 3 get cancelled with each other. At the end we are actually getting the answer as pi centimeter cube. So it implies that the volume of the solid that we have is nothing but pi centimeter cube, which is nothing but the volume of the combination of the solids. So this is how we can find out the volume of the combinations of the solid. I hope all the steps related with this particular example is all clear to you.